Hey, we're live on the Expo live stream. We're talking with Jay Meistrich today about LegendList. How's it going, Jay?
It's pretty good. How are you?
I'm doing all right. We'll give folks just a few minutes to file in here. We're thinking about we were talking a little bit before, and I wanted to ask the audience as they're coming in, and ask Jay about their programmer origin story, because I heard Jay got a first programming job in 10th grade, which is quite impressive. So yeah, in the chat, yeah, let us know, how did you get started in programming? But Jay, yeah, tell us a little bit about that.
Yeah, so my mom sent me to programming camp starting when I was 10, I think. So I was doing camps in the summer. And then I think when I was probably 12 or 13, I started getting really into it. And so I got some books, and I think some of the books came with CDs where you could get some code examples. And so I started coding. And then when I was in 10th grade, I was taking Spanish 4, and my teacher made fun of my accent on the first day, and it made me really sad. So I talked to my advisor, and she said, well, you could take computer science, but it's only for seniors, and you're only in 10th grade. And I said, I want to do it. That sounds great. So I did. I took computer science, and that was good. And then my dad met someone on a plane who worked at a research company called eye tracking, and they hired me as an unpaid intern. And so then after 2 weeks, they started paying me, and then I had a real job, and I learned C#, and yeah, I made a distributed computing system there among a bunch of other stuff.
Wow,
It's pretty fun.
nice.
Yeah.
Yeah, C sharp was one of my earlier. Technically speaking, I have more C sharp experience still than React Native experience, but I feel like I could barely remember how to do it at this point.
Yeah.
Um,
I think I started in BASIC and then in C, but my job was in C#.
cool,
Yeah.
cool. Yeah, I'm trying to like. I guess depends on when you consider the start of it. I mean, I guess I could consider the start of my programmer story in freshman year study hall when I was trying to make an RPG on my graphing calculator. What was fun is that I didn't read the manual. So I went in there and programmed BASIC on my TI-83, and I didn't know that you could insert a line. So every time I forgot to like write a piece of code somewhere and I had to put something in the middle, I wrote a go-to to the bottom of the program and then a go-to back.
Nice.
And this thing
Oh,
that should have
geez.
been like 500 lines of code was like 4,000. It was a nightmare.
That's awesome. I programmed on my TI-89 as well.
Oh, sweet. Oh man, the TI-89 was a boss calculator too. I was
It
always
was fun. Yeah.
I think that was coming out just as I was graduating. I was like, oh my God. Was that one in color? Or that one maybe
No,
not quite yet
no,
color? Oh, but it
no.
had like crazy, like it was almost like a full like blown like Windows operating system on there to some extent,
Yeah.
wasn't it? Yeah.
Uh, it was pretty good, but I was bad at memorizing. So in my statistics class, I wrote a program for every formula I was supposed to know. And
Oh,
so then on the
nice.
tests, I would just run my own programs to solve all the problems.
I shouldn't say this out loud, but like when there was the whole like people just got their graphing calculators and they were worried about like cheating or whatever because people would
Mm.
write the formulas inside their, inside the program itself. And so like they would tell people to like delete their programs before they started the
Oh,
test. So I was
yeah.
like, oh, I wasn't interested in cheating, but I was really interested in the problem space. So I made like a word processor that would save your text to the image files, like the graph image files.
Wow.
So, like, if someone asked to delete your programs, I guess you would lose your word processor, but you wouldn't
Yeah.
lose your answers.
Interesting. Yeah, I knew some people at my school who were just sharing text files of all the test answers to each other between classes. It was bad. Rampant cheating.
And now AI can do it for you. All right, we got some folks filing in the chat here, so I think we're gonna get started with the Expo live stream. We're talking to Jay Meistrich today of Legend about LegendList, his new highly performant full JavaScript list implementation. So yeah, as we get started in here, Jay, who is Jay? What is Legend? And I guess what is LegendList?
Yeah, so I started the product, which is now called Legend, in 2012, I think. It's a productivity app that does documents, to-do list, email, calendar, kind of everything all in one. And so I was working on that for a while, and then I started a new company, Bravely, with some of my friends. and uh, I already had built a state and sync engine, and so I just reused that for Bravely, and so I had all the shared code going between them. So then I just split that out into a library, and then I benchmarked that against other state libraries, and it was not good. And so that made me really upset. And so I went and rewrote the whole thing like 18 times or something until it was faster than all of them. And so that was my other library, LegendState. And then I think it was October. I was at React Advanced, and Mo gave a talk on the new architecture in React Native. And so then I had this theory that maybe I could use the synchronous on layout in the new architecture to make a good list. And so I tried that, and it seemed like it worked. And so I just kept going on it, and then it's actually pretty good now. And then it also turned out that we didn't actually need new architecture to make it fast. It could have been fast this whole time. I just didn't know.
That's awesome. See, I guess that kind of introduces us. Like, I was thinking as we're coming in here about, I think a lot of folks who have been in the React Native space for a long time have had struggles with list performance, list capabilities. And like, I'm thinking back to, gosh, even before, what was the one before we even had FlatList and section list? It was like, I can't even remember what the name of it was. But I got started building on that, and I remember, at one point, the app I was working on, there was this health engagement app, and our designer really wanted to have like very precise positioning. Like, you would have like a list of like health metrics, and you would tap on it, and it would scroll like right in the perfect view, and they would expand just right, and the keyboard would pop up. And I ended up writing like this huge long like thing of like, when the keyboard pops up and you click on this thing and it's halfway down the list, do this, and if you focus on this text. And it was just this big like hodgepodge of code that just didn't like precisely do what I want. So I feel like folks have had like different issues with lists, but we've seen this like kind of like blossoming of really cool stuff, like in terms of list performance, list precision. Back in my time, before like things like legend lists, eventually our designer was like, well, I'm just going to redesign the app so we don't have to do all this precise positioning anymore. But like it sounds like you have a long history with the problems of list performance, even starting on web.
Yes. So it was, I think, 2016 or 17 or something. I decided to rewrite the Legend mobile app in React Native. And so I went through, rewrote the whole thing. It was hard because I had a built-in email client at the time. So I had to do a lot of HTML, which was not easy in React Native. But yeah, got it all working. And then the app was okay. It used FlatList. It was okay. But the problem was it's a text editor. So then I had to dynamically measure every item off screen and then give it a height to the FlatList, or the performance was just awful. And then for web, I was having performance problems. So I made a virtual list on web, and then that was actually very good. And so then some of my users found the mobile web app and said, I'm using the mobile web app on my phone, and it's way better than your native app. Why is that? And then I realized that it was actually just better than the React Native app. So then I converted my app back to mobile web using my virtual list. So I actually had to move away from React Native because of the list specifically. But that was like 2018 or something, a long time ago. So yeah, it's always been a problem for me. And I did build one on web, so I knew how to do it. So then I thought maybe I could come back to React Native finally if I fixed the list problem. But awesome, I do have other React Native apps, by the way. That's just that one.
It kind of like goes to show, it's like, I mean, React, the performance profile of React Native is really like, it could go as far as, any other native app, especially now that we have like new architecture, and we've got like synchronous, all these synchronous back and forth between JavaScript and native. And really all is waiting for in terms of like, say, having this like optimized list performance is someone to build it, someone with the knowledge and background of building this on other platforms and applying those learnings over to React Native.
Yeah, Yeah, I'm very much in the side of React Native apps should be able to feel perfectly native, but there's just a couple core problems. One of them being lists. Yeah.
So kind of as we start in, I know we'll be demoing LegendList in just a moment, but maybe can you describe like kind of at a I don't know, high level, maybe even at a nitty gritty level, like some of like the approach you were taking, because I think it's kind of unique that your library is actually, we all assume that, oh man, someone's gonna have to do some native optimizations to really get lists to perform at the level that Legend List does, but actually it's a full JavaScript implementation. So I wonder if you could
Mhm.
describe like the process of like diving in there and kind of figuring out what to do.
Yeah. So basically, um, well, let me share my screen now because
Yeah,
I
sure.
have. Uh,
Code is worth 1,000 words.
no, not even the code. Although we will get there, but it's so this animation I
Ooh.
like. Let me just full screen that. So yeah, basically, uh, the way FlatList is, it's this virtualization concept, and so it figures out what items are actively on screen, and then renders those items. So as you scroll down, instead of rendering 3, 4, 5, it renders 4, 5, 6. And so that works, but then it has to go through React's reconciler of the array and all that stuff. But it can use normal layout because all the items are in the correct order. But recycling views do what's happening on the right, where you allocate a set number of containers, and then as you scroll, you move the containers. Absolutely. So every item's absolutely positioned. Uh, and so, yeah, as you scroll down, item 3 becomes item 6. To do this, you have to know the height of every item because you're doing the layout yourself. And
Ah.
so that's why the on layout being synchronous in the new architecture is important, because what happens is we have an estimated height, and then as we actually render stuff, we get the actual height, and then we adjust stuff. And so what happens when you scroll down and 6 comes into view is there's basically a few step process of the container is moved down, so 6 renders into it, and then it renders and lays out and then has a size, calls back into Legend List what the actual size is, and then Legend List will update itself with the actual size. So if things shifted, it'll shift things around a little bit. And so that all happens in JavaScript, which I believe is the correct way to do that, because you basically you're triggering React to render a new item, and that has to happen on the JavaScript side anyway.
Mm.
So it's better to be computing what should be displaying and then triggering a render from the JavaScript side. There's a problem, which is that if the items are not close to the estimated size, so if, say, you estimate that everything is 10 pixels tall, or no, let's go the other way. You estimate that everything is 100 pixels tall, but they're actually 50. Then when you scroll down, you're rendering things like 100, 200, 300. But then if you scroll really fast, they'll be shifting up. And so you'll see these like gaps that close really quickly because it takes just one frame to adjust itself. It does not seem to be something we can solve in JavaScript. We can get it really, really fast, minimize that, try to make it happen off screen. But to actually solve that, I think we need the native piece, which is what FlashList does. FlashList is actually on top of Recycler List View, which does all that in JavaScript. And FlashList has a native component that fixes the gaps, basically. So JavaScript will
Okay.
say, render all these items at these positions. And then the native component will say, well, actually, those are a little off. So just shift them around before they actually render. So that native component just fixes the gaps and overlaps, basically. But yeah, even in FlashList, all of the recycling and rendering is all happening in JavaScript.
Oh, cool. I remember not being quite able to put my mind around it as you're explaining it, but this picture like really
Yeah,
illustrates quite clearly how it works. So it
yeah.
sounds like, oh, sorry, go ahead.
I did a lot of searching for the right animation for this, and this one's good. I like it. Yeah.
Like what it sounds like is like what the thrust of Legend List is like if you are pretty upfront and precise with this one a bit of information that you can probably find out about what you're about to render, that you can achieve this very fast performance
Mhm.
that otherwise you would need some specialized native code to do the calculation for you.
Yeah, and a lot of lists have fixed size items anyway, so
Yeah,
then you don't
exactly.
need that part. It doesn't matter. Yeah.
This example reminds me a little bit too, and if folks like if Expo live stream deep cut folks want to go back and find this after this live stream, go ahead because I think it is an interesting example. This reminds me a little bit on the Tamagui live stream. We were talking with Nate about an example on the Tamagui website of a page view where
Mm.
what like you're kind of scrolling horizontally between like one picture to another picture to another picture, and uh, historically like when you have like kind of these like blunt instruments to start with, like say like a scroll view, and you can make the scroll view horizontal or vertical, or maybe a flat list where you can make it horizontal or vertical, but then you can like pin it to an individual item. You can kind of like
Mm.
go like 1, 2, 3 instead of having to smoothly scroll. So what you end up doing to like make sophisticated UIs out of these kind of blunt instruments is you might do something like you see on the left side of the screen, which is you put everything in the list that you need, or at least everything to a certain extent, and then you shift your view.
Yeah.
But if you instead reuse the things you have, in the case of like a page view where you have like one item in the middle and one to the left and one to the right, one to the left or one to the right, you only need three technically to render that.
Yeah.
You don't need 100 or however many items are in there. So if you can put in that extra engineering to reuse those things, I mean, it's a very classic problem that applies to any platform. The less you
Yeah.
have to shove in memory off screen, the better you can do.
Yeah. Yeah, I learned this from I started my career as a game developer. Uh, so my first job out of college was working on a Nintendo Wii game. And you learn
Oh,
very quickly in games you never allocate memory once the game is running. That's why there's a loading screen. So you'll
yeah.
like pre-allocate 1,000 bullets, and then when you shoot, you pull one of them out of the pool, run it, and then put it back in the pool. So you're always recycling everything. So I always had this ethos of like it's crazy in JavaScript how much we just don't care about allocating memory. But because JavaScript's single-threaded, if you allocate too much memory, it has to be garbage collected, and the
Mm,
garbage collector runs on the same thread, and so it freezes everything. So you really don't want to be allocating memory all the time.
cool. That's
So
an
yeah,
awesome example.
basically we're trying to not allocate memory very much. Yeah.
That's awesome. Hey, as you're diving into the more of the demo stuff here, I just wanted to throw out to the audience to let us know in the chat if you have any questions for Jay about Legend List. But yeah, hey, we'll probably touch a little bit towards the end on Legend State as well. So if you have any questions for Jay, yeah, put them in the chat.
Mm.
And I think you kind of actually let me throw this one up real quick to kind of because I think you kind of alluded to this already, where you talked about a difference in FlashList versus Legend List, where it can let FlashList can do this kind of calculation on the native thread, but there is like a performance impact to that. So this might be a good spot to illuminate that further.
Yeah, sure. So I don't think there's a performance implication. That's basically just a correctness fix.
Got it. Oh, okay.
Yeah, so it just makes it look more correct. But yeah, in terms of a comparison, I think most people that have tried it have said Legend List seems faster. There's also some very important features in apps. Like, for example, if you want to make a chat UI, traditionally in FlatList and FlashList, you would invert the list so that if you only have two messages, they would appear at the bottom and then they scroll up.
Mhm.
But then if you invert the list, what that does is it applies a transform scale -1, which just does weird stuff. But also, if you have animations, then they're all inverted. And then if you try to pull them out of the list, like if you want to do a shared element transition, it's crazy because you're pulling it out of a negative scale. So it's easier just to not have that. But it's actually really easy to know the height of the content and then just put padding at the top. So LegendList has an aligned items to bottom prop, which just puts padding at the top. So you can make chat UIs without having to invert it. That may not sound like a huge deal, but it is a pretty big deal.
Yeah, anybody who's built a chat UI from scratch can attest that
Yeah.
the weird things happen. Like the very simple example usually works pretty okay with inversion, but you run into weird stuff pretty quickly.
Yeah. And then there's another prop, which is maintain scroll at end, which if you're within a threshold of the scroll from the bottom of the list, it'll just keep you scrolled there. So when new messages come in, they just appear at the bottom, which you would get for free if you're inverting it, because you just stay scrolled at the top, even though you're at the bottom. But yeah, that works pretty well. And then one of the main things is there's maintain visible content position, which basically makes it so, and I guess you can look at the image here. If you are looking at items 4, 5, and 6, and then item 2 grows by 200 pixels, it'll shift the whole list down by 200 pixels. And then it'll shift your view by 200 pixels also. So maintain visible content position just fixes that. So it keeps what you're looking at where it is, even if stuff above it is moving. And so that's very important for real-time text editors or just all sorts of stuff. Things are changing out of the view. And that's, I think there's been an open issue on FlashList for a long time. But it was important to me to solve that. Because I came at it from, Legend is a collaborative real-time document editor. And so that's something that happens all the time. So that's a key feature. Yeah.
Cool. I guess, yes. Yeah, no, I think so. That okay. Kind of clarifies the different. I mean, obviously, like in your case, you were building it for and I think that's where a lot of great projects come out. Is you have a specific problem to solve where, you could use all the components, you could probably get partway there, but it wouldn't be that great. And this particular experience is really important to be very smooth, and it's it's kind of like the keystone experience of your app. So it's important to optimize, and it's wonderful that then the rest of the community gains the benefits of that in an open source version of that.
Yeah, and once I had this kind of inkling to try this, I think I was at 3 conferences, and so I just asked everyone I encountered, "What are your problems with the list?" And so I got a lot of feedback and a lot of patterns. Yeah, some people gave me some good rants about the problems they had. So that was really helpful.
Cool. All right. Yeah, I guess you're going to show us a little bit more about how to actually use LegendList, and
Sure, yeah.
probably is a good transition in terms of the basics. It actually is more or less API compatible with FlashList. It can basically serve as a drop-in replacement with a few lines of a code change.
Yes. The only difference is, I happen to be on that line right now. FlashList recycles items. So what that means is when a container moves and the item comes into view, it re-renders that container with the new item, but the state does not, or the state is retained. So if you had, say, thumbs up button was pressed, or you had something animated open, when that recycles back into view, it'll still be there. And so you have to go through all these weird hoops to go back to the previous state. There's also a lot of other weird issues with recycling, like if you had a video playing, it might still be there. If there's native components inside them, they might not have unmounted correctly. So it causes a bunch of weirdness sometimes. So that was one thing I heard from a lot of people, was it's really fast, but also the recycling causes a lot of headache. And so LegendList has that optional, has an opt-in thing. So we try to make it as fast as possible without even recycling. And so basically recycle items will reuse the React component and thus reuse all of the native views that were created for it. So if there's already a view and a text, it'll just update the text inside it instead of ripping apart all the native views and then building them all again. So that is a big optimization if your app works with it. So it's opt-in. So if you take your flash list, then you would just only add this one line, recycle items. So yeah, I guess I can show some examples. So this is one that I had an AI generate. Just has a bunch of things with lorem ipsum text. Is that really slow on the stream?
Yeah, it's going to be difficult probably to show the buttery smooth scrolling on stream.
Okay.
But we can see it scrolling though, at least.
Yeah. Okay. Yeah. So here's an example of if I click this, then it just doubles the text. So this is one of the obviously core features is it has to handle resizing. And so then you can also do some, this is a reanimated gesture handler thing. And so I think this will show the problem. Yeah. So when I scroll down, I still have this. It was already opened from the previous container. So this is kind of showing the problem with recycling is you have to then handle when it recycles back into view, what do you do with that? So I think it's currently disabled, but I did that. So we have, wait. Oh, it's the render item. So I'm trying to remember how all this worked. Right, this guy. Okay. So this one we have some hooks. So there's a use recycling effect hook, which when an item recycles, it'll go and close itself.
Oh, so this would handle anything like the obvious easy use case of a recycled component is like if it's all just reacting to props. But if you have state, you need to reset your state. So this gives you an easy hook to do that. Cool.
Yeah. Yeah. So I don't know if you can see it on the stream, but if I open that and then scroll down, it does not.
Yeah, none of the other items are open.
Yeah. Yeah. So what'll happen is when the container moves, it will close the swipeable. It's kind of a bad example because there's an animation on it. So if you scroll fast enough, you'll see it closing. But that's basically the concept there.
But actually, it's a good example because it answers answers Alex's question right here. It does work with reanimated.
Oh yeah, yes it does. There's an animated legend list that works with React Native with reanimated.
Nice.
And then there's also a use recycling state. So this will just set it back to false whenever it recycles. So try to have these hooks where if you're opting into recycling, then it makes it easy to deal with that.
Oh, and so these hooks go in the individual item because this is set per item. So you actually have hooks to.
So
this is the render item function.
That was an old version actually. So those are now just regular imports. So yeah, that's in the render item. You can use the recycling state or the effect. And so that'll, the recycling effect will just be called whenever an item recycles. And it'll tell you the new item, the old item, etc. And then the use recycling state will just reinitialize it back to the state that you give it whenever it recycles. So yeah, basically just trying to make it easy to use recycling when you're managing your own state.
Yeah, I really appreciate the API as I'm seeing it, because it feels intuitive to understand when you're interacting with the individual item versus the whole list. I feel like I'm trying to think of a clear example of this, but I remember a lot of my historical list wrangling. I'm trying to figure out what to do with individual items while I'm inside the entire list component, and my head's just going in weird places.
Yeah. And then I think that's another thing is the other lists have viewability callbacks and stuff, which is good, but it's at the outer list level. And so we have a use viewability hook, which will tell you that within the item itself, which I think is helpful. Yeah.
I was curious on this example because the cards are different sizes, and of course they also expand and contract. where do you set, because you have like a static estimated item size if everything's the same size, but where do you set the particular
Yeah.
size for those different items?
You don't. So they're estimated at 400, and then what happens is as you scroll down, an item's rendered off screen, and then it says I'm actually 320, and so by the time it gets onto
Okay.
screen, it knows the correct size.
So as long as you're close, you're not going to have like weird like jumping effects.
As long as you're close and um, your component's not super heavy, then yeah, it should work. There's also this draw distance prop, which defaults to 250, and that affects the buffer above and below the screen. So if you make that 1,000, it'll give it 1,000 pixels below the screen that it'll render the item into. So if you make that high, then the rendering and layout will happen while it's off the screen and you can't even see it. So by the time it gets on screen, it's correct.
Cool.
But you would want to test that on slow phones and make sure, because that'll render more items and use more memory. So there's a trade-offs there. Yeah.
My one other question in this example, sorry to keep you here for so long, but
Yeah,
it just blew my mind. So you showed the expanding of the cards downwards without losing the scroll position. Can they expand upwards too without losing the scroll position?
Yes, let's show an example of that. So the bidirectional infinite list, this is showing the maintain visible content position. So what this does is I can scroll to the, so I guess the first thing to notice is I started at the middle, and so we don't know the exact height of the items above yet. So as I scroll up and they render, they adjust themselves without messing up my view. And so then as I'm scrolling up, I can pull, when I hit the top, I get the on start reach. And so that will add things to the top. And those all get added without shifting anything. Wow. Running the stream is hurting the performance of this pretty bad. But yeah, as you can see, as I'm scrolling up, you don't see anything shifting. It's just, it's an infinite list in both directions without any weird shift going on.
I can resonate with some of the comments in the chat where like I need this to a time machine to send this back like 6 years to when I was dealing with these very specific problems.
Me too.
Failing miserably.
Yeah. I had this exact problem 6 years ago, and I had to give up on making a React Native app completely because of it. So I think that is a very important feature for a lot of things, is being able to go infinitely in both directions without any weird layout shifts.
Yeah, I think this answers. Oh, sorry. Go ahead.
Also being able to be scrolled to an initial index and be able to scroll up without any weird shifting too.
Yeah, I think some of this answered a question Vusiv had here. If I'm using auto height for a list item, but it's the same across the entire list, what's the recommendation for estimated item size? So it sounds like you don't need to worry necessarily about calculating an on layout. That in most cases you can pick a reasonable size.
So I took a hint from how FlashList handled that. So if you don't provide the estimated size, it'll tell you what it should be.
Oh,
so it'll. Really I went a little bit further than they did, I think, which is if you just scroll the whole list, it'll keep updating what the average item size is, and so it'll keep telling you what the average size is. So basically, render your list. It'll tell you what you should put, and then put that as the estimated. There's also, I think it's a get estimated item size, which I believe takes it, index and an item, and then you can return it a number. So if you know a little bit more about individual items, maybe you could say for headers they're 20, for items they're 150. So you can be a little bit more specific with it there.
Oh, neat.
And then I guess I'll show another example. So this was taken from my friend Alex made this video or movies demo for testing performance stuff. So I don't think this is going to scroll well on stream, but this is a lot of horizontal lists that have hundreds of movies in them. And so this was a really good performance test.
So this is a vertical legend list with a bunch of horizontal legend lists.
Yeah. And so for this one, you know the size of each one because they're the size of a movie poster. So that is not really an issue. It's more just the fill rate of rendering so much stuff. Yeah. And then another quick example is this chat example. So this is also probably going to look crazy. I don't know why streaming kills my CPU so much. It's pretty wild. But
the stream will take all available resources and some that aren't available.
Yeah. So it's looking pretty good. So I'm sending messages. It's maintaining the scroll at the bottom. I close this keyboard now. Yeah. And so then I can just keep sending messages. It should keep me scrolled at the bottom. And so I think I skipped over the interesting part is at the beginning, it knows that there's only 3 messages and the height they are. And so it just puts padding at the top so that they are stuck at the bottom. So that's just align items at end, maintain scroll at end. And so that'll do all that for you.
Very nice. I remember often using a lot of imperative commands for that, like, oh, I just sent a message, so I'll stick a scroll to bottom on my inside at the end of my message send. And to have that as a simple prop is very convenient.
Yeah. And then it's also nice because if you're not scrolled to the bottom, you're trying to look at something. So it shouldn't scroll you away from it. So I think it's a little bit better than just always scrolling to the end.
Oh my gosh. I did not realize it. So it only maintains scroll to end if you're already at scroll to end. Oh.
Yeah.
That is so cool.
There's a threshold, which I believe is a percentage of a screen. Yeah. So if you're scrolled to halfway to the end, it'll keep you at the end.
Yeah.
But I think it defaults to 0.1. Yeah.
So basically you can fine tune that where you're like, if you're like halfway between, like in the middle of the last message, you might as well just scroll to the end because you're close enough anyway.
Right. Yeah, exactly. But I always find it really annoying when I'm in an app that my friend sends me a new message, so it scrolls me to the bottom. Well, I was up there searching for something. Yes. You scrolled me away from it. It's so annoying.
Oh my God.
Yeah.
I used to feel so much pain on behalf of my users from that. I mean, I'm sure they felt the pain even worse, but every time I ran into that, like, oh, yeah, I'll just refresh state when I'm going back to this previous list. And then, that sometimes I was dealing too, like the limit, like tools like this help you if, say, your API, like I feel like a lot of, front end folks, we might have just the API that's given to us, and the backend guy might be working on different priorities. I've often been in situations where the backend guy is just trying to keep the lights on because the user load's overwhelming, and it's going to be hard for me to ask him for like a really good paging UI. So I need to like build these optimizations in my data layer to make sure I keep stuff loaded. But then I also have to be thinking about what happens when I scroll this thing around and go back and forth, and to have convenient props like that where I can just think a little bit less, the front end can be just a little bit more in control, so I can go focus on whatever the heck is going on in my data layer a little more.
Right. Yeah.
Cool.
Yeah.
Thank you. I think I saw the screen up there. Whatever example, but I saw the bidirectional infinite list up there, so I hope we get to that one definitely soon.
Oh, I did already.
Oh, you did? Okay, I'm sorry.
That was this one. Yeah.
That is bidirectional. I did not realize that was the bidirectional list. Oh my gosh.
Yeah.
So what are the maybe? Yeah, I hate to
guess I didn't go the other direction.
What are the load methods look like that? Like what props are specific to the bidirectionalness of it all?
On start reached and on end reached.
Oh, perfect.
Yeah. So I did not write this example. So yeah, this just prepends some stuff when you hit the top, and then on end reach will append to the end of it. Yeah.
Rad. We got a couple questions queuing up in here about various specific implementation details. Let's see if I can throw a couple of these up here. Let's see. Frank's got some good ones in here. What are your best list item recommendations in all your findings? Less state if possible, less nested views?
I don't know if I have any specific ones. Just, yeah, make it as light as possible, basically. So both of those things, I guess. There's one thing is I would suggest that the list items should use external state if they have state instead of coming out of a context or coming out of prop drilling, because if you need to prop drill that, you're going to have to re-render the whole list, which is going to cause you a bunch of pain. So if, for example, your like selected item comes down as a prop, then the list is going to have to re-render every item to re-render that. So if the one item that needs to re-render because it got selected re-renders, that's the best way. And of course, you should use LegendState for that, but that's a whole other thing.
I was about to say the same. Like LegendState is an example of a library that's very good at you can put that, you can reference a piece of state inside of just the list component and have it just re-render that component. So it seems obviously if you're using LegendState at the same time you're doing LegendList, you're very cognizant of that scenario and probably making both of them work very well together.
So that would be the main thing, I would say. Like
Frank also, I think this one's kind of related to like what would constitute a heavy component that you might start to see some of these more complex scenarios start to buckle, or like you might need to start doing some optimizations on the items themselves.
An image that's too big and you're resizing it, that's certainly a problem. I guess the end of his question is lots of state changes or re-renders. So that my big motto in React is the 3 words, which is render less often. And so if your list items are re-rendering a lot, that's going to be a problem no matter what. I think probably video is going to be pretty heavy. If something is doing a lot of things on the native side that might be doing a bunch of stuff, I think video does a lot of native side processing. And maybe just views are more nested than they need to be. I think hooks actually have more of a performance implication than people think. I did some testing in LegendState, and just like running a use ref and a use memo, 1,000 components on screen, it has an impact. Just having less hooks is actually kind of important. So if you have list item components that have like 40 use states in them, that might be a problem. I think people think those are free, but they're not. So that, you might want to go from 40 use states to 1 use state that's just a big object, maybe. Depends on how you're doing it. Or obviously use LegendState is the best way.
Yep. I assume does LegendState, I mean, I guess if you I don't want to transition too hard from LegendState if you want to show more stuff on LegendList, but like LegendState, if you're referencing like several different props, it would still try to coalesce those into a single state update, or I guess Yep. Cool.
Well,
cool.
React kind of does that for you, because it uses the usync external store hook. And so if 4 different external stores change, then that'll just trigger 1 re-render.
Cool. Yeah, so I wasn't sure if you wanted to show anything else on Legend State here, or if I remember Legend List, but I know we wanted to hit a little bit in the last few minutes on some update on Legend State as well.
Yeah, I think I'll just show a couple of things. So one
Oh,
is
cool.
this kind of the cool new thing in the new architecture is there's synchronous layout, and so uh, there's a few different ways to do it. We found the fastest way is the unstable get bounding client rect. So if you run this in a use layout effect and then get that, that seems to happen like many, many milliseconds earlier than the on layout function gets called. And so we can use this to more immediately update the item size and recompute what has to be on screen. So that's making a big impact on the speed on the new architecture. And then I think the other interesting bit here of how this works is I made this. Where is all this stuff? Yeah, I made this really basic signaling system. And so the way that the container stuff works is when the container changes position or changes the item that's in it, the list signals down into the container to re-render itself. And so when the container positions change, when the items inside them change, the list itself does not re-render, the array does not re-render. The only thing that re-renders is just the container. And that has a very large performance impact.
Huh.
And
Yeah.
that's I think a big key to why it's so fast. And that's kind of something I learned from Legend State, which is one of the goals of it is to have the smallest possible re-renders. So I think one of the reasons FlatList is slow is because it's always re-rendering the whole item array. And so we want to target those re-renders down just as small as possible. So the container is it's using that little signaling hook to get the item key and then the position also from that. So that makes it much, much faster. I think that's probably the most interesting thing about the implementation.
Yeah. I mean, it's really sound advice for a lot of performance problems, when you have an app at scale and it's, you're seeing it slow. It comes down to like, how much are you rendering? How often are
Yeah.
you rendering it? And to have the
Yeah.
list handling that automatically for you to at least it's not going to optimize the rest of your app, but at this one critical part that's probably your app has a lot of lists, and this
Yes.
is doing that optimization for you, targeting your render to a very minimal space.
Yeah.
That can help you a lot. They can get you pretty far down the line in terms of
Yes, for
fixing
sure.
performance.
Yeah. There's also a couple other interesting little hacks in here. So trying to remember which one it is. Oh, it's a different one. So there's this other interesting hack which does this. So for the container size, it makes an animated value using React Native animated for the size of the total list size. Right. So yeah, it makes an animated value, and when the signal tells it changed, it sets the animated value. So it never has to re-render the size because it's only setting the animated value. So we use this in a couple places for setting an opacity, for setting a size, because we're trying to minimize the re-renders so much that we don't want to have to re-render the whole list every time the size changes. And so we can just set that on an animated using a set value, which sets it immediately. So we're not actually animating anything. We're just using animated to be able to quickly set values into the native layer without going through the whole React render process. So that's a fun little hack that actually
Amazing.
has a pretty big performance implication. So that's probably a pretty widely usable hack that people could do is animate things you don't actually need to animate if you don't want to re-render.
Huh. That is cool.
That's a fun one. We spent a lot of time just finding like every little micro optimization possible because they all stack. I think
I think that
that's
speaks
all
a
the
little bit.
demoing I can do.
I think it speaks a little bit to the question of take off my shirt. Where do you find the motivation to work on Legend List? It's not like a weekend project after all. It sounds like a lot
That
of it comes from finding these little things that make a big impact.
Yeah, it's funny because I don't currently have a business need for a list because Legend, I switched it away from React Native because I didn't have a good list. Now I can come back, but that's a whole larger project. Um, but it was just like everybody needs it, and I've been so mad about it for a long time. So I want it to be good, basically. And there's just some part of my brain that just optimization just really gets me. So if there's a fun project I can optimize, I'll go 8 hours on it, forget to eat until it's done. Yeah.
Well, on behalf of the community, we all appreciate that part of your brain. Cool. Yeah. So, yeah, that was awesome. Really appreciate you showing us all the inners of Legend List. Yeah,
Yeah.
really wanted to hit on because I know Legend State's been plugging along too, and for folks interested in Legend State as well, what if you could speak just for a few minutes on like what's new with that?
Yeah. So Legend State, basically it's a state library, but it's the fastest state library, and that is it mainly because it lets you use what some people call signals, other people call observables. It gives you the ability to do fine-grained rendering, so you can basically target your renders really, really small. And so it just, one of the primary goals is just to make everything faster. But the other is it's a full local first sync engine. Uh, so we have plugins for a bunch of different backends like Keel and Supabase, and there's a React Query plugin. There's a CRUD plugin that you can build your own stuff on top of. And so that does all the hard local first sync engine stuff. That is just, it's so hard. And so if you're trying to build a local first app, I think it's the best way to go, but it's worth looking into, I think. And so what's going on with that is it's been in beta for a long time because I was trying to get a lot of feedback and fix bugs and stuff. And then we had to kind of change stuff around a little bit to be more compatible with the compiler. So it is now as of a few beta versions ago. So I'm trying to just finish up the documentation for that. So hopefully that'll be ready to call version 3 stable soon. But we're using it in production in 2 apps, and a lot of other people are using it in production. So it's, even though it's in beta, it's pretty stable.
Awesome. Yeah, it was a kind of exciting thing to see, even at the very beginning, seeing that sync piece, that very, very much at the center of that. I was like, oh, this is very intuitive. Like, there's instructions right here on how to, like, I remember Firebase was one of the first one, and you just been adding so many more,
Yeah.
and struggling with like, oh, how much code would I have to write to do this with whatever my existing state engine is, and here it is handled in a simple kind of plugin structure.
Yeah. Yeah. And I can tell you from experience, it's very hard. You don't want to build it yourself.
Sync is hard. Problems you should
It
not try
is.
to tackle on your own, unless you're Jay.
Yeah. I did not know. I may not have attempted it had I known.
Awesome. Yeah, thanks so much for demoing that and showing that off. A couple good kind of concluding questions in here. Of course,
Yeah.
Is Legend List and Legend State for the matter available for use? And I think the answer is yes.
Yes.
What's the best URL to go for that?
Well, Legend State is legendstate.com.
Cool, cool.
And then they're both at legendapp.com/open-source. But if you go to
Awesome.
legendapp.com, you'll see them there.
Awesome.
Or if you
Legendapp.com.
legendapp.com, go to the footer, and you'll see an open source link there. Or yeah, it's legendapp.com/open-source. I should make a better URL for that.
Or just look up Legend List. You'll find it right away. Legend is this first search result. And I know you said earlier that you were getting some folks helping you with some issues on LegendList. John was asking here. Oh, there. Thank you, Beto, for putting the URL up
Thank you.
there. I was like trying to figure out how to do that. I'm like, oh, I'm gonna break something. But John was asking here if there's any open issues or future goals that the community can start to help with.
There's a couple open issues, but I think we've got a pretty good handle on them. They're very minimal at this point. I think I'm trying to think of, so sticky headers is a bit of a sticky issue, but there's this guy, Michael Bilenko, who's been doing a lot of work on it and helping a lot. And he's got a lot of PRs he's working on to fix the last open issues. So I think it'll be ready for 1.0 pretty soon. But yeah, if you want to just try the beta, see if you can find any bugs. Even better if you find them, fix them. That would be great. And then I know there's something. Oh, I think at some point it'd be cool to do like a Mason review. Some of the other ones do that by having multiple lists for each column, which is crazy. So I'd like to do that in just one list if possible.
So what's a Mason review?
That's when you have images of different sizes and then they all like fit together.
Oh, okay. Gotcha.
Yeah.
I don't know what that was called.
Yeah.
Yeah. So it sounds like the evergreen open source request is give this thing reps, try it out, take it through its paces, apply it to your unique scenario, because everybody's got their own unique list scenario and needs, and we'll keep making it better. And that way, the more we try it out.
Yeah, I want to get it really stable for 1.0, so help me find any problems.
Awesome. Well, thank you so much for joining us. We really appreciate you, Jay, telling us all about LegendList and the other cool Legend open source things that are going on. Anything else you want to plug before you head out here?
No, I don't think so. Just check out LegendList, LegendState, and Legend itself.
Awesome.
Yeah.
Appreciate that. I appreciate you all joining us. Great questions today on the Expo live stream. And check us out next Wednesday. We have the Bolt.new folks coming on and to talk about writing Expo apps with AI at Bolt.new. So until next time, yeah, looking forward to that one. Yeah, thanks everyone for joining us. Thank you, Jay, and we'll see y'all later.